Okay, so this question says, a reflector is attached to a bicycle wheel at a point 17 centimeters from the center of the wheel. There's a center right here, and I'll just say, put that up here, somewhere like right here. I'll say that's 17 centimeters. The radius of the wheel is 30 centimeters, so this is 30. The wheel rotates clockwise, so it rotates this way, and it says it takes 4 seconds for a full revolution. That's 4 seconds. All right, this can be represented using the sinusoidal model. I'll just put that down here. It's going to be, they say that it's going to be h and t, so h of t equals, we have a cosine b x minus c plus d. First thing you need to realize is, for a, it says, assuming the reflector is at the topmost position at t equals 0 here, develop a model for the height h in centimeters of the reflector above the ground at any time in t seconds. All it's saying is, can you start the graph? This is a wheel. And where do wheels start? They start on the ground, right? Let's say this is the ground. That's 0 on the y-axis right there. I'm going to start drawing my graph. I'll say I have, this will be my x values are t, h values are y. So I want to draw something else. This is the topmost position at 17 centimeters here. If it rolls down this way, it goes down 17 centimeters here. So then your position for your reflector is here and here. And that would mean that here it's 13 centimeters from the ground because the radius is 30. Here it's 13 centimeters from the top of the wheel because the radius is 30. Now I need to represent that on my graph here. So here, like I said, the minimum for my reflector here is going to be here. I'm going to start there. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 30 here because that's my radius. Because if you look at my reflector is always going to be above or below my radius here from this picture, which means that my minimum is going to be at 13 centimeters from the ground. If this is the ground here, this is the ground. If it's 13 centimeters from the ground, that's where it starts. So I'll just write 5, 10, 15. So 13 is right here somewhere. 13. So I'll just put a little dash line so you know that's the minimum where the reflector can go. The maximum would be, so 17 up here. So you're probably thinking, okay, well, what goes up here? Well, this is 30, and this is 17. The difference 13. I'm going to end up at 47. This is going to be from here, the ground from here, from the middle up, 47. 30, 35, 40, 45, 47 here. So my sinusoidal graph is going to be in between these two, minimum maximum. And the reason why I put 30 here in the middle is because if you notice, that's my radius. My radius is right here in the middle. So that's my midline. So I'll draw a line like that. Then it says the topmost at t equals 0. So t is 0 right here. That means it's right there. T equals 0. Then it says it takes 4 seconds to complete one revolution. So down here I'll go, oh, 4 seconds. I'll say this is 1, 2, 3, 4. So in 4 seconds, I need to do a complete revolution. And because I'm starting up here, that's why I put cosine here. It doesn't start at 0 down here, it starts up here. So one full revolution will go here, down like that. That's the minimum. Goes back up at 4 there at the maximum here. All right. So now I have my height above and below represented here. Now the next part, it says it wants you to say, revise your model so the reflector at the bottommost position t equals 0. So first thing I have to do is actually write my model. So based upon my picture, this is what I have. h of t equals, now look at my picture here. My baseline is at 30 here. It's going up 17 and also down 17. So my amplitude is 17 here. Cosine. And then I have b. Well, I don't know my b yet, do I? Let's look at it. I'm starting from here to here. My period would be from here to here like that. That's one period. That would go in front of x here. I figured that out. That's x. And then it's not moving left to right. I'm going to put parentheses there. And you see my baseline is up here at 30, so that'd be plus 30. So the only thing I have to find is my period. So my period, it goes along with my time here, my x. So my x is 4, isn't it? So that's 4. That's also 4. Your period is always going to be 2 pi or whatever the distance is there. Mine is 4. So that's how I get 2 pi over 4, which is going to give me pi over 2. So then my equation here is 17 cosine pi over 2 x plus 30. 17 means I'm going up 17, down 17. 30, that's my midline. And then pi over 2, because it's one revolution in 4 seconds. That means is, again, 2 pi represents 360 degrees. I'm going around 360 degrees in 4 seconds. That's how I get that. Now for part B, it says, okay, revise your model so that the reflector is at the bottommost position. That means it wants to be down here. That's the bottommost position. And the way I do that is I think about that just conceptually. If this represents the model, how do I represent the model when I'm down here? Well, technically, if you're looking up here, that's plus 17, minus 17, because you have positive 17 here, up 17, and then this one's down 17. For part B, you just say, oh, it's negative 17 cosine pi over 2 x plus 30, and that's it. That represents you're at the bottom part of the function. Now for part C, it says revise your model so the reflector is at the rightmost position. You want to see when your reflector is going to be right here. Again, it's still 17. So this is where the whole transformations comes in. I start back with my regular functions, this equals 17 cosine 2, or sorry, pi over 2 x plus 30. Now, my transformation is now I'm over to the right one. I'm right here. Well, think about it. My transformation tells me this is what's telling me to move left to right. X is changing. My x here is time. How much time does it take to get to this point? Well, if the whole thing takes 4 seconds, each part takes 1 second. That's 1 second. That's 2 seconds. This is 3 seconds. So then in 1 second, my reflector is right here. All that's saying is, oh, well, my x is technically t. I don't know why I keep writing x here. It should be 17 cosine pi over 2 t plus 30. Now it's saying, oh, well, if you're at the rightmost part, that means your time has gone to 1 second. So it'll be 17 cosine pi over 2, and then t plus 1 plus 30. And then the last part, it wants to know when I'll be on the outer edge. So to revise that model, you'll actually have to change it to sine. Because if you're on the outermost part, you're right here. Now you're starting at 0. Sine starts at 0. So your model will actually be, I can write it here somewhere, 30 sine pi over 2 t plus 30. And why is it 30 sine? Because look, it's right here. We've moved over 30 because we're at the leftmost part.
Can I ask a question really quickly?
Yeah, go ahead, yes.
So for part C, how did you get plus 1? Like, why did you do that?
So for part C, again, we're messing with t, time. So right here, like I said, I should have been writing, because these are all actually should be t's instead of x's. So I'm changing t. It tells me how much to change it by. Now it's saying, okay, in the rightmost position here, that means you've gone from here to here. And since it takes 4 seconds for a full revolution, to get to here, a quarter revolution would take 1 second. And so you're just saying, it's the same model, just plus 1 more second. So I'm adding 1 second to time here like that.
Yeah. Okay, yeah.